Hi guys, good day everyone. Hope you're doing good there. Today we like to discuss regarding the topic simultaneously process under the topic of capacity bottleneck. Okay, before we move into the topic, I just like to give a brief explanation regarding our team, which is the subject is about operation system design, presented to our lecturer Dr. Noor Hidayah binti Abu, and then myself KARTTHI Analaki Pugalnathan, and my fellow members are Ainur Nabilah binti Abdul Wahab, Fairuz Najwa binti Rodzan, Noor Hafiza binti Abdul Rahim, Maisurah binti Abdullah, Faradiana binti Zulkifli. So without lacking our time, we just move on to our topic now. Alright guys, now we are in our second slide regarding bottleneck analysis. Bottleneck analysis, as we know, we have four subtopics under bottleneck analysis. First of all, parallel process, simultaneously process, service process, and last but not least, batch process. But for our presentation now, we'll just going to focus for simultaneously process only. Before we move to our next slide, I will just like to give a formal explanation for simultaneously process. Simultaneously processing is the process of combining discrete and unconnected stimuli or activities into a single group or whole to assist in comprehension and interpretation. It involves the comprehension of the relationship of and between separate entities and its relation or position to the whole. For further understanding, for understanding in a picture form, we move to our next slide, and we will discuss about a sample example for the simultaneously process. So let's move to our next slide. Hello guys, now we are in our third slide, bottleneck analysis in simultaneously processing. Okay, the diagram shows a standard process of cleaning teeth, which contains 1, 2, 3, 4, 5, 6, 7 elements. Okay, so let's observe what is inside the diagram. The first process is check-in, follows up with takes X-ray, develops X-ray, hygienist cleaning, and below we have right below we have X-ray exam, and then dentist and checkout. Okay, from the diagram we can see that the 5 elements are in orange color and 2 are in blue color. Okay, so in this simultaneously processing from parallel or other parallel processing, service processing, and also batch processing, this hygienist cleaning and X-ray portion varies from parallel or other processing. Okay, so let's go in detail. For this standard process for cleaning teeth, the first will be check-in, the second will be takes X-ray, the third will be develops X-ray. What is the fourth? Okay, the fourth could be hygienist cleaning or X-ray exam. So we will have two possible pathway, and then the fifth will be dentist and the sixth will be checkout. Okay, so that means this hygienist cleaning and also X-ray exam will be occur simultaneously. Okay, so for after we observe the diagram, the first thing we should do is we should figure out all possible path must be compared. Okay, so for this diagram we can see check-in, takes X-ray, and develops X-ray is a compulsory process. Okay, so hygienist cleaning and X-ray will be occur simultaneously. So the possible way will be check-in, takes X-ray, develops X-ray, hygienist cleaning, dentist, and checkout is the first possible path. The second possible path will be check-in, takes X-ray, develops X-ray, X-ray exam, dentist, checkout. Okay, these two will be the possible path, because hygienist cleaning and X-ray exam may occur in a simultaneous time, in the same time. Okay, so let's we move to our next slide. Okay guys, now we are in our fourth slide. Hopefully this fourth slide will give you a clear explanation. Okay, just now we have figured out regarding the two possible path or two possible process that we can find out based on the simultaneous diagram. Okay, the first question, what is the bottleneck? As we know, bottleneck is the most slowest activity that happens in throughout the process. Okay, so now they are asking what is the bottleneck. Okay, so we observe again the diagram. We see from the diagram, check in, it consumes 2 minutes per unit. Takes X-ray, it consumes 2 minutes per unit also. Develops X-ray, it consumes 4 minutes per unit. Hygienist cleaning, 24 minutes per unit. X-ray exam, 5 minutes per unit. Dentist, 8 minutes per unit. And last but not least, checkout, 6 minutes per unit. Okay, bottleneck is the most slowest activity throughout the process. Slowest activity means the most highest time consumption that the element which the element contains is the bottleneck. So as we know, hygienist cleaning is the most time consumed activity, because it is 24 minutes per unit, whereby other elements are below than 10 minutes. So the bottleneck for this process will be the hygienist cleaning process, which is at 24 minutes. Okay, we move on to our second question, which is what is the hourly capacity? Hourly capacity. They are asking for hourly capacity, but the time which is given for the elements in the diagram is in minutes. Okay, we should know how to convert. So for hourly capacity, 1 hour equivalent to 60 minutes. Okay, so we convert the hour into minutes, which is 60 minutes. Okay, the formula will be 60 minutes divided by the bottleneck process minutes. Okay, as we know, just now we answered the bottleneck question, and we have obtained 24 minutes as an answer. So for this hourly capacity, 60 minutes divided by 24 minutes, which is the bottleneck of the process. So the answer will be 2.5 patients. Okay, we move on to our third question, which is regarding which process is the bottleneck process. Okay, from our slide 3, we able to identify two possible pathways or we can say process, because two elements two activities are happening simultaneously. Okay, so we come again the two process. The first process will be check in, takes X-ray, develops X-ray, hygienist cleaning, dentist, and check out. The second path will be check in, takes X-ray, develops X-ray, X-ray exam, dentist, and check out. Okay, I explain again why these two possible path, because hygienist cleaning and X-ray are happening simultaneously. Okay, so that means we able to compare. There is two process we can identify from the diagram, which is path A, path B, as I mentioned just now. Okay, now from that path A and path B, okay, we can name it as X-ray exam path and also hygienist cleaning path, because this hygienist cleaning and X-ray exam makes this process to split into two pathways. Okay, the first is X-ray exam path. Okay, now we need to identify the longest path, which is the bottleneck path. Okay, so for the X-ray exam path, we need to sum up all the time consumption, okay, for the first X-ray exam path. Okay, for the X-ray exam path, the process is the path elements are check-in, takes X-ray, develops X-ray, X-ray exam, dentist, and check-out, as we know just now. Okay, so for the check-in is 2 minutes, plus takes X-ray 2 minutes, plus develops X-ray 4 minutes, plus X-ray exam 5 minutes, plus dentist 8 minutes, plus check-out 6 minutes. Sum up total, we have 27 minutes for X-ray exam path. Following is a cleaning path, hygienist cleaning path. We have check-in 2 minutes, plus takes X-ray 2 minutes, plus develops X-ray 4 minutes, plus hygienist cleaning 24 minutes, plus dentist 8 minutes, plus check out 6 minutes, total 46 minutes. Okay, so we should compare the X-ray exam path and also the cleaning path. X-ray exam path is 27 minutes and cleaning path is 46 minutes. So the longest path involves the hygienist cleaning the teeth patient should be complete in 46 minutes. Okay, because that is the highest time consumption, 46 minutes, and X-ray exam path is 27 minutes. So that hygienist cleaning path will considered as the bottleneck for the process is called the bottleneck process. Okay, so just let's we move on to our next slide. We'll discuss about the a sample exercise which is similar to the example as we see it now. Okay, so let's we move on to our next slide. Okay guys, we're in our fifth slide now. Fifth slide is regarding exercise similarly to our sample just now. Let's see what is the diagram is about. The diagram we can see 1 2 3 4 5 6 7 elements with 3 similar elements: solving, sanding, drilling, welding, and 3 similar elements which is assembly. Okay, solving it takes 6 units per hours, sanding 6 units per hours, drilling 2.4 units per hours, welding 2 units per hours, assembly 0.7 units per hours. Okay, before we move on to the questions, first of all, after we observe the diagram, the first thing we should do, these 6 units per hours should be in minutes per unit. Okay, so the first thing we should do, we should convert this unit per hours into minutes per unit. Okay, how we should convert? Okay, the first thing, hours, we know that 1 hour equivalent to 60 minutes. So 60 minutes divided by 6 units equivalent to 10 minutes. Sanding 60 minutes, which is equivalent to 1 hour divided by 6 units. Sanding activity is also 10 minutes. Drilling activity 60 minutes, which is equivalent to 1 hour divided by 2.4 equals to 25 minutes per unit. For welding activity, 60 units, which is equivalent to 1 hour, divided by 2 units, and the answer is 30 minutes per hour. And last but not least, assembly, 60 minutes, which is equivalent to 1 hour, divided by 0.7 units. The answer will be 85.71 minutes per unit. Okay, so after we convert, now we move on to our question now. Okay guys, this is the continuity for the 5th slide. A production process at KARTTHI manufacturing is shown in the figure just now. The drilling operation occurs separately from and simultaneously with the sawing and sanding operation. It means the simultaneous operation is sawing, sanding, and also drilling. Okay, so from this from the information we know that these two activities, these two operations are simultaneously, so we can able to identify two possible paths. Okay, which is sanding, which is sawing, sanding, welding, assembly is the first path, and the second path will be drilling, welding, and assembly. Okay, so I emphasize again, this is because the drilling operation occurs separately from and simultaneously with the sawing and sanding operation. Okay, so because the drilling is occurs separately and at the same time of sawing and sanding. Okay, that's why we can able to identify two possible pathways. The first pathway, sawing, sanding, welding, assembly, and then the second will be drilling, welding, and assembly. A product needs to go through only one of the 3 assembly operation. Okay, that means we have 3 assembly operations in the figure, but only one operation will occur in one process. Okay, because the operations of assembly are in parallel. Okay, so let's move on to our questions. Which operation is the bottleneck? Okay, as we know, bottleneck is the most slowest operation. Okay, and at the same time the highest time consumption that we found out from the figure. Okay, we observe the figure where sawing will be 10 minutes per unit, as we convert just now for all the operations. Sawing will be 10 minutes per unit, sanding will be 10 minutes per unit, drilling will be 25 minutes per unit, welding will be 30 minutes per unit, and assembly will be 85.71 minutes per unit. Okay, so as we know, for the bottleneck, the most time consumption will be the bottleneck. We may select the assembly operation as a bottleneck. Okay, but we should highlight from the information, which is a product needs to go through only one of the 3 assembly operations. Okay, so that means the assembly operations are working in parallel. Okay, if the assembly operation is working in parallel, that means 3 operators are working in assembly process and in assembly operations. Okay, but for a product needs to go through only one of the 3 assembly. Okay, so what we should do, 85.71 minutes, okay, we should divide by 3, because the assembly is operated by the assembly process, all 3 process is operated by 3 operator. Okay, but we only going to we only have to add on one assembly in one process. Okay, so 85.71 minutes we should divide by the 3 operators. Okay, which is we able to get 28.57 minutes per unit. Okay, for per assembly for per assembly process. Okay, so that means 85.71 divided by 3 equivalent to 28.57 minutes for assembly process. Okay, so now we should compare the time consumption between all operations to find out which is the bottleneck. Okay, so that means the sewing, sanding, welding and drilling, the time consumption remain unchanged. Okay, for assembly, the assembly, the time consumption will be 28.57 minutes per unit. Okay, I emphasize again, this is because a product needs to go through only one of the 3 assembly operation. Okay, only one of the 3 assembly operation. That's why we should divide the 85.71 minute divided by 3 because of 3 operator. Okay, so now we have to compare the time consumption of all the operations, and the most time consumption is falls for welding operations, which is 30 minutes per unit. Okay, so now we move on to our next question, which is what is the bottleneck time. Okay, so for the first question, which operation is the bottleneck, is the welding. At the same time, which is the bottleneck time, which is the welding consumption time is 30 minutes per unit. So the second answer will be 30 minutes per unit. Okay, C, what is the throughout time of the overall system. Okay, this question we should able to identify the both possible path as we identified just now. Okay, the most possible path will be sewing, sanding, welding, assembly will be the path A, and drilling, welding and assembly will be the part B. Okay, throughout these two pathway we should we have to find out which one is the bottleneck time, which is the bottleneck cycle time. That means the most highest time consumption. Okay, the similar way as the previous sample is applied here. For path A, for sewing, sanding, welding and assembly, 10 minutes plus 10 minutes plus 30 minutes plus 85.71 minutes. Okay, so total up we can we can able to get 135.71 minutes. Okay, now we should calculate the second pathway, drilling, welding and assembly. 25 minutes plus 30 minutes plus 85.71 minutes. So total up we able to get 140.71 minutes. Okay, obviously it's shown that the most time consumption is for drilling, welding and assembly process, which is 140.71 minutes. So what is the throughout time of the overall system? The answer is 140.71 minutes, because it is the bottleneck for the two processes that we able to identify because of the simultaneous operation. Okay, so the answer for C will be 140.71 minutes. Okay, so we move on to our last question. If the firm operates 8 hours per day, 20 days per month, what is the monthly capacity of the manufacturing process? Okay, for this question, first of all, what we should do, 60 times by 8 times by 20 divided by 30. Okay, the 60 is the overall 60 minutes, because we should convert the hours to minutes. So it means 60 minutes times by 8 times by 20 days. Okay, because 20 days per month, times by 20 divided by 30, because monthly in a month we have 30 days. Okay, so 60 times by 8 times by 20, answer divided by 30, we able to get 320 units per month. Okay, that's all for the simultaneous process. Thank you for lending me your ears, and I hopefully these slides and this explanation give you a good explanation for the simultaneous process. Thank you.